Welcome to Master Chem Academy. So, in this session, you are going to learn oxymercuration-demercuration reaction. Okay. So, what is that reaction? Alkenes in presence of mercuric acetate and THF with water. Okay, tetrahydrofuran with water. What it forms? Hydroxyalkyl mercury compounds. Hydroxyalkyl mercury compounds, which on reduction with NaBH4 plus NaOH, okay, what it gives? Alcohols. So, it is a two-step process. Step 1, this is step 2. So, this step 1 is called oxymercuration step. What is step 1? Oxymercuration step, okay. And now step 2 is demercuration or reduction step. Okay. So, what is first step? Oxymercuration step. And what is second step? Demercuration or reduction step. Okay. So, I will explain this with one example, that is propene CH3 CH double bond CH2, CH3 CH double bond CH2. So, what is mercury acetate? So, we can write this as HgOAc taken twice, because mercury is bivalent. So, acetate means OCOCH3, OCOCH3, HgOCOCH3, actual structure of this one. So, as this is acyl group, so we can write as HgOAc, okay, HgOAc taken twice, and THF with water. So, what it gives? Hydroxyalkyl mercury compound. So, how it is? CH3COH, here HgOAc, okay. So, HgOAc. So, one of the HgOAc at one carbon, at another carbon OH group is attached. How it is attached, that we will discuss in the mechanism. Okay. So, how to remember this? Hydroxyalkyl mercury compound. Hydroxyalkyl mercury compound. So, this on reduction with NaBH4 with NaOH. So, what it gives? A reduction takes place here, okay, and it gives propene. What is the final product? Isopropyl alcohol. Okay, alcohols are formed. Okay, this is a important points. This is a two-step process. First step is called oxymercuration. Oxymercuration, and the second step is called demercuration or reduction step. Okay. So, it completes in two steps. So, these are the two steps. And one more important point here, it is anti-addition or trans-addition takes place. This is regiospecificity. What is the regiospecificity? Okay. So, anti-addition, trans-addition, this OH and HgOAc to the unsaturation, how it is, they are attached in an anti-manner, okay, because of anti-addition or trans-addition. That's why this is highly regiospecific. And one more important point here, it is final conversion of mercury compound as Hg atom. Okay. So, that what it means? So, what are the byproducts here? Hg plus ACOH. ACOH means CH3COOH, acetic acid. Okay. From here two OACs are there. Okay. One OAC is leave as ACOH, and final conversion of mercury compound as mercury atom. Okay. So these are the important points in this oxymercuration-demercuration reaction. Okay, now let us discuss the mechanism. Before that, so how in your examination, how it is asked, example for this is, so here mercury acetate, so how can you write this? HgOAc taken twice, and here HgOAc taken twice, THF H2O, THF H2O, or everything. Here you can write here THF H2O and NaBH4 OH minus. What is the product? Okay, so you may get question like this. So what it means? This is step 1. Okay, so oxymercuration step, and this is step 2. So what you have to write here? Final product. What is the final product? It is alcohol. From options A, B, C, D. From options you should find out, so the correct option, okay, of oxymercuration-demercuration reaction. Okay, so we can expect question like this. Okay, so now let us discuss mechanism for this reaction. Okay, so how it is? So first HgOAc, this mercuric acetate, by ionization it converts as Hg plus OAc with one lone pair plus OAc minus. Okay, so how it is? Hg, we know that HgOAc. Okay, so AC means, so it is acetyl group, COCH3. Okay, now this OAc will leave as OAc minus. Okay, that's why Hg gets positive charge. So and it has one lone pair. Okay, it is metal, so having one lone pair. So Hg plus OAc. Now this Hg plus OAc, so this electrophile attack on unsaturation system. How it is? CH3, here Hg plus lone pair OAc. Okay, now attack and formation of bridged complex. Formation of bridged complex is formed. So that is mercury bridged complex. Okay, so here it is cyclic Hg plus OAc. Hg plus OAc. Okay, so this is cyclic mercury bridged complex. Okay, so this is formed. Now this with H2O. Okay, so along with THF tetrahydrofuran, H2O is there. So this attack of H2O takes place. So here two ways are there to neutralize this positive charge: delocalization of this bond towards this side, or to delocalization of this bond towards mercury. Okay, this bond towards mercury or this bond towards mercury. Okay, two options are there, but here because of the delocalization of this bond towards mercury to neutralize this positive charge, that leads to a more stable carbocation than this option. Okay, we have two options. So if we select this option, so it is a primary carbocation. It is a primary carbocation. So if we select this option, okay, so this will become a secondary carbocation. So that's why, as secondary carbocation is more stable than primary carbocation, always attack of H2O takes place on the more substituted carbocation or more stable carbocation. Okay, that's why what it gives: CH3, here this one HgOAc. Okay, now here OH2. So as these electrons are utilized here, oxygen gets positive charge. Okay, oxygen gets positive charge. Now, so to neutralize this positive charge, this loss of H plus minus H plus, loss of H plus takes place, okay, that leads to give, what is that, CH3 COH COH, okay. Now HG OAC, okay. This is because of this positive charge. To neutralize the positive charge, removal of H plus takes place and leads to the formation of this compound. So what is this compound? Hydroxyalkyl mercury compound. Hydroxyalkyl mercury compound, okay. So this total, this one in the mechanism total from up to this is step 1. What is that? Oxymercuration, okay. This oxymercuration step, after this, what is that step? NABH4 OH minus, OH minus. So what is this? It is a reduction step. Reduction takes place here. So we know that NABH4 is a reducing agent, so it can provide H2 hydrogens, okay. That's why, so how it converts? It converted as CH3 COH. Now already here CH2 is there, with the hydrogen it will become as CH3 CHOH CH3, okay, isopropyl alcohol. And how it is? So here HG, here it is HCS, here it is converted as HG and ACOH. Already O minus, ACO minus is there with H plus ions. So with H plus ions, OAC minus, so it is converted as ACOH, okay. So and HG. So this is a reduction step. So oxymercuration step and a reduction step, okay. So this is the process to write the product of oxymercuration and a demercuration step, okay. So in your examination, if it is given like this, okay, how to write product directly, okay, just place here OH and here hydrogen. It's a, as a whole it is a hydration reaction and Markovnikov's product, okay. How to write the final product of oxymercuration demercuration step? So it is important trick to write the product of oxymercuration demercuration, okay. The product of oxymercuration followed by demercuration is a anti-Markovnikov's addition of water. Just remember as it is a anti-Markovnikov's addition of water, okay. If you remember this, you can write the product easily. So Markovnikov's product of water, okay, not anti-Markovnikov's. So it is a Markovnikov's product of addition of water, okay. That is the product of oxymercuration demercuration, okay. So if you remember this point, just this point, H2O Markovnikov's product, okay. So with this you can write the product. So take this example, and what is the Markovnikov's product of hydration? This is the Markovnikov's product, because we should attach OH minus at carbon of unsaturation which has less number of hydrogen atoms, okay. It is having one hydrogen, here it is having two hydrogens. That's why attach negative reagent OH minus at a carbon of unsaturation which has less number of hydrogen atoms. So and hydrogen at more number of hydrogen atoms, carbon with more number of hydrogen atoms, at that carbon attach hydrogen. So that leads to give Markovnikov's product, okay. Just write Markovnikov's product of hydration, okay. If suppose in a reaction, if in your examination if it is given as CH3 CH2, okay, so this is CH3 COO taken twice, HG, okay, that means HGOAC taken twice, and next THF H2O, and next here NABH4 OH minus, okay. So if it is given like this, So what is your answer? This is your answer. And next, here if it is given as in place of H2O, if it is given as D2O, okay, so H2O is water, so what is D2O? Heavy water, that is D2O. What is your product? Okay, that is product is CH3OD. Just this hydrogen you should replace with D, because in place of H2O what we have replaced? D2O. So look at this mechanism. Here what is this step? H2O is added. H2O is added. Now what you should add here? D2O. As D2O is added, so OD. Because of loss of OH, H plus, okay, so what you will get? OD. Okay, so now final product is having OD. In place of OH, just OD. Okay, if in case of, here it is H2O only, here it is NABD4 is given. NABD4, okay, hydrogens replaced with deuterium. Now what is the product? Here your product is should be, as it is H2O, it should be OH, and here CH2D. This is the product, because what happened here at last step, okay, now it is H2O only, so just replace with H2O, hydrogen, and next here hydrogen, okay. Now here what is the step? Addition of H2, but here what is the addition of NABD24? Addition of D2, okay. That's why CH3, CHOH, CH2D. So that is the product. Okay. Here this is very important. So it may be applicative type. This is a general reaction. So application type, one application is replacing H2O with D2O, and the second application is replacing NABH4 with NABD4. Okay. So with that, so how to write the product? Just remember these points. Okay, now some more examples for oxymercuration-demercuration. Okay, so we know that this is first step, oxymercuration step, and this is second step, demercuration. Okay, so what is the trick or tip for this reaction? How to write the product? Addition of H2O, Markovnikov's product. Just this is the trick to write the product. Okay, hydration, just to do hydration. So as per Markovnikov's rule, so H2O means OH minus H plus. OH minus you should attach carbon of unsaturation, which has less number of hydrogen atoms. So that's why, so in the first case COH, CH, okay, C. So here it is CH2 and CH3 become as CH3OH, okay, CH2, here 1, 2, 2, 4 valency satisfied, CH3. Just here by at the unsaturation, what we are doing, just addition of OH minus and H plus at each carbon atom. Okay, at one carbon atom attaching OH and another carbon atom. So here at this carbon atom, so you are attaching one more hydrogen. Okay, initially it is CH, so one hydrogen with one hydrogen it become as CH2. Okay, one hydrogen, one OH. So that's why, so this is the product. And next second, here it is double bond CH2. So in this unsaturated carbon atoms which has less number of hydrogen atoms, here that's why at this point attach OH, and at this carbon CH2, at this carbon attach hydrogen. How it become S? So here it is CH3 group and OH. And now this one, here attach at this carbon atom So it is having less number of hydrogens. That's why it at this carbon atom attach OH, and here this one is become as CH2. Actually this become as CH3. Okay, CH3, because hydrogen is attaching here. So this is the product. Okay, in this case there is no rearrangement. That is also important point. There is no rearrangement. Okay, because mercury cyclic transitions, mercury cyclic mercury compound is only formed, no carbocation is formed in this reaction. That's why no rearrangement. Okay, if it is a carbocation, what happens here? Alkyl group should migrate, okay, to get a stable carbocation. But here no carbocation formation, that's why no rearrangement. That you should remember. Okay, that's why. So the product should be this one only. And next this one. So with CH3. So here this carbon, and now comparing carbons are 1, 2. This one. Okay. So here there is no hydrogen, but here we are having one hydrogen atom. That's why. So as it is having 0 hydrogen atoms, so OH should attach here and hydrogen should attach here. Okay, so that's why this is the product. Okay, this is called oxymercuration. If in an example, if it is this H2O and THF, H2O and THF is replaced with CH3OH, CH3OH. Okay, so that is how to write the product. Here it is given as HgOAc twice, and next NaBH4 OH minus. Same reaction. Okay. So for this, so just as like H2O, CH3OH addition, Markovnikov's product. CH3OH addition, Markovnikov's product. So for first compound, so that is carbon. This carbon is having less number of hydrogens. That's why here OCH3 it is having OCH3 minus and H plus. Okay, -1 should be on carbon which has less number of hydrogen atoms, and here at this carbon atom hydrogen H will be attached. Okay, so HOCH3. So this is one of the application. Okay, if it is replaced, H2O is replaced with CH3OH. Okay, so this is called acetoxy. Okay, methoxy mercuration and demercuration. Okay, what is this? Methoxymercuration-demercuration, or alkoxymercuration-demercuration. So this is one more application. Okay, this is about oxymercuration, demercuration, reaction, mechanism, and different examples, applications. Okay, so this is the end of this topic. Thank you.